We present Hypervis, a novel tool for visually explicating the model checking results of hyperproperties. Hyperproperties can express complex relations but have to hold across multiple executions of a system. A model checker tries to validate such a hyperproperty for a given system and returns a counterexample when two executions exist that violate the hyperproperty. Based on a causal analysis that automatically identifies the cause of the violation, these counterexamples are explicitated by Hypervis. In this example, a Trojan system is considered. The formula view shows the hyperproperty in an hyper-LTL format. Here, it is stated that it must always be the case that if the atomic proposition bound is symmetric on both executions, the emergency variable must be symmetric in the next time step. In the explanation view, the violation is verbalized, stating that the globally subformula was violated as the bound input was true on both traces at time step 2, but the emergency output was different at T3. The trace view shows the two executions in more detail. Here, the columns show the atomic propositions, the rows the time steps, and the cells encode the binary polarity values. The leading state variable is automatically extracted and is in fact a combination of the two ledgers named state 0 and state 1. The timeline view shows the executions in a more compact way, with time flowing from left to right. The polarity of the atomic proposition is again shown as filled or hollow rectangles. The labels are shown on hover. Finally, the graph view represents the system as a transition system, where the nodes show the states and the edges the possible transitions. The goal is now to identify the specific violation and its cause. The explanation view does not only provide textual statements, but also allows to enable the explanation highlight. Now, all relevant parts are indicated. We can see that the bound variables was indeed similar at T2, but the emergency output differed in T3. When stepping through the example, we can see that at T2 both traces are in different states. However, while the trace pi prime will correctly move from S1 to the emergency state S3, the other trace moves from state S2 to S1 despite the present bound. Thus, we would need to edit the system and add the missing transition from S2 to S3. This editing of the system is currently supported in Hypervis through a mockup-like functionality, allowing to change the underlying textual representation. The combination of easy-to-parse encodings, clear color mappings, and indication of relevant elements alongside interactive mechanisms such as linked highlighting or stepping through the example make Hypervis a powerful tool for analyzing counterexamples. Further, the integrated editing functionalities for formulas also allows for updating and fixing a specification directly within the interface. Importantly, Hypervis is also highly useful when considering larger examples. Here we have a still medium-sized example of a bakery protocol featuring multiple program counters. Through the highlighting, we can see that a violation is occurring at time step T14. By activating the filter option, the example becomes way more easier to analyze. Now we can see that on pi, one specific program counter proposition is marked, while another one is marked on pi prime. It is also visible that the premise of the top-level implied statement is a globally formula that was satisfied through the present input. The implication formula was then violated as the PC00 proposition on pi prime differed from the PC10 proposition on pi. This illustrates how the highlighting and filtering within Hypervis can help to break down larger examples and understand them step by step. In conclusion, Hypervis can serve as a highly valuable explication interface for model checking results, especially when compared with the current status quo of going through textual output of command line tools.